Graph the solution set to the absolute value of x plus 1 is less than 5 and express it in interval notation. This is similar to one of the problems that we did before, but it's a little bit more complicated because we have x plus 1 inside the absolute value instead of just x. And we're going to address that in just a minute, but first I want to talk about what the solution is going to look like, because we can say a few things about the solution before we even do any math. So because we have an absolute value is less than a number, we know that that means we're going to be shading the inside, because it means the distance is less than 5. So when our distance is very small, we've got to stay inside. Also, because it's less than but not equal to, we know that that's going to require an open circle. So we know that on the number line, we're going to have two open circles, and we're going to shade in between them. However, those circles are not going to be at 5 and -5 because we have this whole x plus 1 here. So we have to figure out where those circles are going to go. And the way that we do that is by taking the inequality and looking at the corresponding equation. So we're going to look at the absolute value of x plus 1 is equal to 5. So we've changed this less than symbol to an equal symbol. And now that we have an equation, we can actually solve this by splitting it up into two separate equations. And when we solve those, we're going to get two x values, and those are going to be where the open circles are. So let's go through and do that. We've got x plus 1 equals 5, or x plus 1 equals -5. If we solve by subtracting 1 on both sides, we get x equals 4, or here we end up with x equals -6. So those are going to be the endpoints of our intervals. So let's see, 2, 4, 6, 8, etc. And then -2, -4, -6, -8, etc. Now, we know that we're going to have open circles because it wasn't allowed to be equal to 5. So we are going to find 4 and -6 on the number line, and we're going to put open circles there. And we know that we're going to shade the inside because the absolute value or the distance was less than a number. So we know we're going to have to shade in between here. And so these are our solutions. And if we want to put this in interval notation, we know that that's going to be parenthesis -6, comma 4 parenthesis. Now, if we want to check, we can plug in any number in this interval to see if it works. Let's pick 0, because 0 is easy to plug in. If we go up to the original inequality and we plug in 0, we've got 0 plus 1 on the inside of the absolute value, and 0 plus 1 is 1. The absolute value of 1 is 1, and we know that 1 is less than 5, so that works. We know that that's a solution. You can pick any of the other numbers inside this interval and plug it in to check. In fact, if you want to pause the video right now, you can do that. You can pick any of these numbers, 1 or 2 or -4, and check to see if it works. And then also, you could plug in these endpoints, 4 and -6. But if you end up plugging in 4 and -6, what's going to happen is you're going to end up with 5 on the left-hand side, or -5. And when you take the absolute value of that, it ends up being equal to 5, not less than 5. So those are open circles because those are the numbers that make this an equation when we really want it to be an inequality. So those are not part of the solution. Because we looked at part of the method in the last problem and part of the method in this problem, I do want to put all of the instructions for solving these problems in one place. So the very first thing we do to figure out where the two circles go on the number line is we take the inequality and turn it into an equation and solve. And we can write that a little bit more simply by saying solve the corresponding equation. So instead of solving this inequality, we solve the equation, and we know how to do that because we did that in the last section. And then once we have our two solutions, we can plot them on the number line. So we plot these solutions, and in particular, using open circles for inequalities less than or greater than, and we would use closed circles if we had the inequalities less than or equal to or greater than or equal to. Because we know if it's allowed to be equal to, then those points end up being solutions. And then the third step is shading, and we shade inside if we have the absolute value of something is less than a number, and we shade outside if the absolute value is greater than a number. So these are the steps that we're going to use whenever we're solving any of these absolute value inequalities.